Welcome back. So we're about to start the third section in this flipped AS chemistry classroom. Okay, and the first video in this section is going to be on mass spectrometry. So your targets for this video are to be able to label a diagram of a mass spectrometer and be able to explain what is happening at each stage. Okay, so before we start looking at this diagram, what is mass spectrometry? Later in the section, in the chapter, we look at uses of mass spectrometry. But for now, you can just think of it as a way of determining the mass of atoms or molecules. Okay? Now you need to be able to go through both the process and be able to decipher the results. We'll do that in a later video. For now, we're just going to go through this process, make sure you know the different parts of the mass spectrometer, and be able to explain what is happening at each stage. So it starts over here. Now, first of all the air is taken out of the mass spectrometer. Must be a vacuum for this to work. And then your sample is added. Now, it has to be in the gaseous form, okay? So your gaseous sample is injected at this point. But this isn't normally asked about in the questions. The first part, which occurs here, is termed ionisation. So this is the term which you need to learn, okay? Quite often you're asked to label a diagram or go through the process, and this is one of the key terms. Okay? But really there are two things which are happening. Now the first thing which happens is that an electron gun fires high energy electrons at your sample. Now the way this is described in mark schemes in general is that your sample is bombarded. Now this word just means repeatedly hit with high energy electrons from an electron gun. An electron gun is just something which fires electrons, okay? Now what is the point of hitting your sample with high energy electrons? Well, these high energy electrons knock off other electrons. These electrons have enough energy to actually remove electrons from your sample. And obviously if you remove electrons, the sample itself becomes positive. Now this could be a molecule, this could be an atom, but if you remove an electron, overall it will become positive. So for instance, I could just represent this. Your sample plus energy makes a plus gas plus an electron. You have knocked off an electron from your sample, forming positive ions. Now this is important because you need these positive ions. It is only the positive ions which can be detected by the mass spectrometer. It's the only ones which go through the whole process. So this first part is all about getting positive ions. But there's also something else which happens, which is essential for being able to determine what your sample is. Now this still comes under ionisation, but there's a second part called fragmentation. Now this is not normally asked about in the basic questions about the process, but it's important you know about fragmentation for when we come to analysing the actual results, the mass spectrum. Now what fragmentation is, when your sample is bombarded with high energy electrons, sometimes it will break apart. So sections will break away from your molecule. So for instance, if we look at an example, let's say ethanol. And when you bombard it with high energy electrons, it can break into pieces. So in this case, you have C2H5, overall being a positive fragment. You also have OH, and there's that electron which has been knocked off. But it doesn't have to be like this. There are quite a lot of splitting patterns, and you don't have to know exactly what happens to each molecule. Just be aware that during this process, the molecule will break apart into different fragments. So this is the first stage, ionisation. Don't call it fragmentation, okay? This also occurs in ionisation, but the overall step the key term you need to know is ionisation. If you want to write this in your notes, pause now, because I need the space, so I'm going to rub it all out. So your second stage, which occurs here, is called acceleration. So this is stage number 2. Now what happens here is that using an electric field, the positive ions are accelerated into the rest of the equipment. They are focused at this point here. So they are all in one stream at this point. Okay, so what would you write? So positive ions accelerated by applying an electric field, or you could also call it electric potential, both terms are fine. And they're focused into one beam by passing through slits. So this is step 2, okay? First one, ionisation. Second one, acceleration. So now we're into the main part of the equipment. Okay, so step number 3, which occurs at this part of the machine. As you can see, labelled here, we have a strong electromagnet. Okay, now this magnet causes what is called deflection. So what happens here? Now, once they're accelerated into one beam, they are all moving at the same speed. They have the same amount of energy. But the different fragments, will have different masses. So when you apply this magnetic field, they are affected by different amounts. If you think of a road, if you think of a lorry driving down a road and then having to turn, it's going to take quite a while to get it to go because of its mass, okay, its momentum. Now, if you have a tiny little car, a Beetle or whatnot, it's going to be able to turn much quicker, okay? It's not going to require as much force. The same thing happens here. The heavier the fragments, it tends to go straight for longer, okay? It takes much longer to actually turn, whereas the light fragments, the ones with low mass, are deflected a lot. So the heavier fractions, because they are deflected a lot later, they have a longer route to actually get to the end. And because they have a longer route, and they're all traveling at the same speed, the ones with the longer route will take longer. So at this point, the different sized fragments are separated using the magnet. And because they're separated, they will have different lengths they have to travel to get to the end. Okay, this is important for the last stage. Magnetic field deflects the fragments. That's mainly what you would write down for a basic question. And then for more detailed ones, the understanding part. So the fragments with the higher mass are deflected less than those with a lower mass. They have more momentum, therefore it requires a greater force. Therefore, the initial force provided by the magnetic field isn't enough to deflect them. They need more force. So this is the third stage, deflection. Only one stage left. So the final stage occurs here, and this is detection. So sensors can detect when they are hit by fragments. Now in the previous stage, the fragments were separated based on their mass. Because they had different lengths of the journey through the equipment, they arrive at different times. The smallest fragments arrive first, and then as they get heavier and heavier, they keep on arriving at different time points. Now, what happens at detection is these fragments are detected, and this is linked to a computer which produces your mass spectrum. And this is the final stage. So you had ionization, acceleration, deflection, detection. And those are the 4 stages of the mass spectrometer. Okay, you need to know the names and you need to be able to describe what is happening at each point. The sentences I've written down would be enough to get you full marks in any of these basic questions on the process of mass spectrometry. So strange words like bombarded, deflection, detection, any of these which you wouldn't necessarily think are chemistry words, you still need to learn them. Now we've gone through it, hopefully you should be able to label basic diagrams of mass spectrometers and be able to give the key terms for what is happening in each part. And you should be able to explain what is occurring using as many key terms as possible. Okay, so just like normal, make sure you complete your notes and I'll see you in class.